All right, today we're diving into one of the universe's most incredible light shows, one you can't even see with your own eyes. It's something called Bremsstrahlung Radiation, and believe it or not, it's how we map the hottest, most energetic, and what looks like the most invisible parts of our entire cosmos.
So, picture this. You're looking at a cluster of galaxies. You can see the bright, sparkly galaxies, no problem. But what about all that space in between? I mean, it looks like just nothing, right? So how on earth do astronomers map something that looks completely empty? Well, that's the big mystery we're going to crack today.
Okay, so here's our game plan. First, we're going to take a look at this so-called invisible universe. Then, we'll track down a mysterious glow. After that, we'll figure out what's causing it, this breaking radiation, and learn how to decode its secrets. And finally, we'll see how all of this comes together to actually map the cosmos. Sound good? Let's go.
All right, first things first, let's set the stage for our little cosmic mystery here. What is actually hiding out there in the dark spaces between the galaxies?
Well, it turns out that space isn't empty at all. Not even close. It's actually filled with something called the intra-cluster medium. And get this, it's not some cold, dead void. No way. It's an incredibly hot gas, a plasma, that's been superheated to millions of degrees. We're talking about a massive, fundamental part of our universe that is, somehow, totally invisible to us.
Okay, so you might be wondering, if we can't see this plasma, how do we even know it's there? And that brings us to the first big clue in our investigation. This weird, unexpected glow coming from all that emptiness. Yep, this superheated, totally invisible stuff is shining all the time. But not with the kind of light you and I can see. It's shining with something way more powerful. These huge regions of space are just flooded with high-energy X-rays. And that glow, that's our smoking gun.
But wait, how do we even see X-rays from space? Well, we can't do it from down here. We need special eyes in the sky. And that's where things like NASA's Chandra X-ray Observatory come in. It's a telescope designed for one thing, to see this exact kind of light. It lets us take pictures of things that are completely invisible to a regular telescope.
So, what in the universe is making all these X-rays? It's time to pull back the curtain and meet the culprit, a process known as breaking radiation. The official name is Bremsstrahlung. It's a German word that literally means breaking radiation, which is a perfect description. It's what happens when a charged particle, like an electron zipping through space, gets knocked off its path and slams on the brakes. That sudden slowdown is the #1 source of X-rays we see in these huge galaxy clusters.
Let's break it down. It's actually pretty simple. You've got an electron flying through that hot plasma. Step 1. Then it gets a little too close to the nucleus of an atom. Step 2. The positive charge of that nucleus yanks on the electron, pulling it off course and making it slow down. It literally breaks. So all that energy of motion, that kinetic energy, has to go somewhere, right? It can't just disappear. Boom! It's instantly released as a high-energy particle of light, an X-ray photon.
Okay, awesome. We found the source of the glow. But just seeing the light isn't enough. If we want to use it to map the universe, we have to learn to read it, to understand the language it's speaking. And that means decoding its unique fingerprint, which we call the continuous spectrum.
Now this is the really important part. Bremsstrahlung light is special. See, other types of radiation, like characteristic radiation, only give off light at very specific, discrete energy levels. It's like a staircase. You can only be on step 1, or step 2, or step 3. But Bremsstrahlung, it gives off X-rays across a whole continuous range of energies. It's not a staircase, it's a perfectly smooth ramp.
And that smooth ramp, it's an absolute goldmine of information for scientists. The shape of that ramp tells a whole story. For example, by looking at how high the energy goes on that ramp, we can figure out exactly how fast the electrons were moving, and that tells us the temperature of the plasma. The overall brightness of the light, that tells us how dense the gas is. So just by looking at this light, we can measure the temperature and density of this invisible stuff from millions of light years away. It's incredible.
All right, let's put all the pieces together. We've got our mysterious light source, we've got our decoder ring to read it. Now it's time to see how this all becomes a map of the cosmos.
And here's the payoff. This breaking radiation, it's the key to everything. It hands scientists the exact data they need to figure out the physics of these gigantic structures. We're talking their temperature, their density, and even how they act and evolve on a truly cosmic scale.
You know, there's a quote that just sums this all up so perfectly. It says Bremsstrahlung acts as a bridge between electricity and light. And that's just beautiful, isn't it? It perfectly captures how this basic interaction between charged particles, that's the electricity part, creates the actual photons, the light, that travel across the entire universe for us to eventually see.
And that's really the bottom line here. It solves our mystery. Bremsstrahlung radiation is like the universe's own built-in flashlight. It shines a light on the things we could never see otherwise, giving our X-ray telescopes exactly what they need to map out the hottest, most extreme places in the entire cosmos.
It really makes you think, doesn't it? We figured out how to use X-rays to see the hottest, most violent parts of the universe. So what other cosmic secrets are out there, just hiding in plain sight, waiting for us to find the right kind of light to finally see?